Silence stretches across the universe, not the quiet of a calm night on Earth, but a deeper silence that fills the space between galaxies. Modern telescopes scan the sky every second. Massive radio dishes listen carefully for any whisper of intelligence. Computers analyze signals from distant stars, yet the result remains the same. Nothing answers back. This silence is strange because the universe is unimaginably large. Astronomers estimate that the observable cosmos contains hundreds of billions of galaxies. Each galaxy holds billions, sometimes even trillions of stars. Around many of those stars orbit planets. In recent years, scientists confirmed that planets are not rare accidents. They are everywhere. Space missions discovered thousands of worlds beyond our solar system, and statistical studies suggest that the Milky Way galaxy alone may contain hundreds of billions of planets. Some of them orbit in regions where temperatures allow liquid water. Water means chemistry. Chemistry means the building blocks of life. When scientists first realized this, many believed the conclusion was obvious. Life should be common. Civilizations should fill the galaxy. Signals from advanced societies should travel across space. Yet every experiment searching for those signals returns the same result. The sky stays silent. This mystery became one of the most unsettling questions in modern science. If the universe is so large and planets are so common, why does every search for intelligent life return nothing at all? Physicists and astronomers spent decades trying to answer that question. Their investigations led to disturbing possibilities. Some explanations suggest that life itself might be incredibly rare. Others suggest that intelligent civilizations rarely survive long enough to explore the stars. Some theories say that the laws of physics may make interstellar communication almost impossible across such enormous distances. And a few ideas are even more chilling. They suggest that somewhere in the chain from simple chemistry to advanced civilization, there may exist a nearly impossible barrier, a step so difficult that almost no species ever crosses it. Scientists call this barrier the Great Filter. If that filter lies behind humanity, then reaching intelligence may already be an extraordinary cosmic miracle. But if the filter lies ahead, the silence of the universe may be a warning about the future of civilizations like ours. Careful observation of space has already produced several surprising clues. Over the past half-century, enormous radio telescopes scanned millions of stars, searching for artificial transmissions. No confirmed signals appeared. Astronomers searched for giant alien structures around distant suns, objects so large that they would block starlight in unusual patterns. None have been confirmed. Even the search for spacecraft or probes in our own solar system has revealed nothing unusual. Meanwhile, new discoveries about planets keep strengthening the puzzle. Earth once seemed special. Now astronomers know that planets form easily around stars. Rocky worlds appear common. Some systems contain multiple Earth-sized planets orbiting in stable zones where temperatures could support oceans. In other words, the raw ingredients for life appear across the galaxy. Yet intelligent civilizations remain invisible. Physics also introduces another harsh reality. Space is unbelievably vast. The nearest star system beyond our sun lies more than 4 light-years away. That distance means light itself takes over 4 years just to arrive. Current human spacecraft would need tens of thousands of years to travel that far. Between the stars lie distances so extreme that even advanced technology may struggle to cross them. Communication faces the same problem. A message sent across the Milky Way could take tens of thousands of years to arrive. A reply might require another tens of thousands of years. Entire civilizations could rise and disappear during that time. This cosmic scale may isolate intelligent species so completely that they never discover one another. Another possibility challenges assumptions about life itself. Life on Earth required a long chain of unlikely events. The planet formed in a stable orbit around a relatively calm star. It developed liquid oceans. A magnetic field protected its atmosphere from solar radiation. Plate tectonics recycled minerals through the crust. A large moon stabilized the planet's tilt, helping maintain long-term climate stability. Over billions of years, life slowly evolved from simple molecules to complex cells, then to animals with nervous systems, and eventually to intelligence capable of building technology. Each step may be far more fragile than scientists once believed. If any stage rarely occurs, intelligent life could be extremely uncommon across the universe. Some researchers now suspect that advanced civilizations might also face dangerous limits. Technology gives immense power, but it may also carry risks. Nuclear weapons, environmental collapse, runaway artificial intelligence, or other unknown dangers could shorten the lifespan of technological societies. If most civilizations exist only briefly before disappearing, the galaxy could remain mostly silent, even if intelligent species appear from time to time. One civilization might emerge thousands of light years away, flourish for a few centuries, and vanish long before another civilization begins to explore the stars. The universe might be filled with short flashes of intelligence that never overlap in time. This video explores the physics behind these unsettling possibilities. Step by step, the journey will examine why scientists once expected the universe to be full of life, why the silence of space shocked the scientific community, and how modern physics tries to explain this cosmic mystery. The ideas discussed here come from real research in astronomy, astrobiology, and theoretical physics. Some of these theories challenge comforting assumptions about humanity's place in the cosmos. Others reveal how rare and fragile intelligent life might be. By the end of this exploration, the universe may look very different. The silence of the stars may no longer feel empty. Instead, it may carry a profound message about existence itself. Stay with this story until the end, because the final idea changes the meaning of the silence completely. If the universe truly contains almost no intelligent life, then humanity occupies an extraordinary position in cosmic history. Conscious minds capable of understanding the laws of nature might be incredibly rare. The thoughts inside human brains may represent one of the few places in the universe where atoms learn to question their own existence. That possibility turns the search for alien life into something deeper than curiosity. It becomes a question about the role of intelligence in the entire cosmos. Welcome to Feynman's chalkboard, a place where science reveals the hidden logic of the universe, and where the biggest questions in physics are explored in clear and simple ways. If exploring the deepest mysteries of space excites curiosity and changes how the universe is seen, subscribe to the channel and join a growing community fascinated by the strange reality uncovered by modern physics. A powerful expectation once shaped the scientific view of the universe. Once astronomers realized how many stars exist, the idea that life might be common began to feel almost unavoidable. The Milky Way galaxy alone contains hundreds of billions of stars. Observations over the last few decades revealed that many of those stars host planets. In fact, planets appear to form naturally whenever stars are born. Dust and gas swirl together, small rocks collide and merge, and eventually entire planetary systems take shape. This discovery changed the way scientists think about the cosmos. Earth was once believed to be extremely unusual. Now it appears that rocky planets may be common throughout the galaxy. Some orbit close to their stars and burn under intense heat. Others drift in frozen darkness far away. But many lie in regions where temperatures allow liquid water to exist on the surface. Water is not just another substance. It is the foundation for chemistry that can build complex molecules. Complex molecules can organize into systems capable of storing information and replicating themselves. These are the early steps that may eventually lead to life. When astronomers first realized how many planets exist, a new question appeared almost immediately. If planets are everywhere, then why would life appear on only one of them? The universe seemed far too large for life to exist only on Earth. Scientists began trying to turn that expectation into numbers. Instead of asking vague questions about life in the universe, they wanted a method to estimate how many intelligent civilizations might exist in our galaxy. In 1961, an astronomer named Frank Drake proposed a simple way to think about the problem. His idea became known as the Drake equation. It was not really meant to give a precise answer. Instead, it served as a framework for breaking the mystery into smaller questions. The equation begins with the rate at which new stars form in the galaxy each year. Stars are the engines of planetary systems, so this number determines how many opportunities for life might appear. The next step considers how many of those stars actually develop planets. For a long time, this number was uncertain, but modern observations show that planets are extremely common. Many stars host entire families of worlds. The equation then moves to another factor. Among those planets, how many might provide environments suitable for life? Scientists often focus on planets located in a narrow region around their stars where liquid water can exist. This area is sometimes called the habitable zone. The equation then asks how often life actually begins on such planets. That step remains deeply mysterious. Life on Earth appeared surprisingly early in the planet's history, which suggests that the process might not be extremely difficult. But scientists still do not know exactly how non-living chemistry first transformed into living systems. The equation continues by asking how often life evolves into complex forms capable of intelligence. Simple microbes may exist on many worlds without ever developing brains, tools, or technology. On Earth, it took billions of years for life to move from simple cells to complex animals. Intelligence appeared only very recently in geological time. Even then, it arose in only one species capable of building advanced technology. The final part of the equation considers how long technological civilizations might survive while sending signals into space. If a civilization exists for only a few centuries before disappearing, the chance of detecting it becomes extremely small. But if civilizations last for millions of years, the galaxy could be filled with signals. When scientists plug optimistic estimates into the Drake equation, the results suggest that our galaxy should host thousands of intelligent civilizations. Even cautious estimates sometimes predict dozens or hundreds. With numbers like these, the Milky Way should not feel silent. Signals from advanced society should cross the sky. Alien technology might even be visible across interstellar distances. This expectation leads directly to one of the most famous questions in modern science. During the early days of nuclear research in the 20th century, physicist Enrico Fermi raised a simple but powerful point while discussing extraterrestrial life with colleagues. The galaxy is ancient. If intelligent civilizations appear even occasionally, then some of them should have had millions of years to expand through space. A civilization that develops interstellar travel could slowly move from star to star. Even if each journey required thousands of years, a determined society might still spread across the entire galaxy within a relatively short period on cosmic timescales. The Milky Way is more than 13 billion years old. That amount of time is enormous compared with a few thousand years of recorded human history. If intelligent life has existed elsewhere for even a small fraction of that time, then at least one civilization should have reached extraordinary levels of technological advancement long before humans evolved. According to simple reasoning, evidence of such civilizations should already be visible. This observation creates what scientists now call the Fermi Paradox. The paradox emerges from the clash between two ideas that both appear reasonable. On one side stands the vastness of the universe filled with stars and planets. On the other side stands the silence of our observation. Telescopes searching the sky detect natural signals from stars, galaxies, and cosmic explosions, but none of these signals clearly originate from intelligent technology beyond Earth. Radio astronomers have spent decades listening for artificial transmissions. Sophisticated instruments scan millions of frequencies across the sky, searching for patterns that could indicate communication from another civilization. Yet no confirmed signals have appeared. The silence becomes even more puzzling when scientists consider how quickly advanced technology could spread across space. Even extremely slow spacecraft could eventually reach nearby stars, establish colonies, and send new expeditions outward. Over millions of years, this process could continue until a civilization occupies large regions of the galaxy. If this has happened even once, traces of that expansion might still exist today. One explanation begins with a simple fact from physics. Space is unbelievably large. Distances between stars stretch far beyond the scales humans encounter in everyday life. The nearest star system beyond the Sun lies more than 4 light years away. Light itself travels at the fastest speed allowed by the laws of physics, moving through space at nearly 300,000 kilometers per second. Even at that incredible speed, it still takes more than 4 years for light to travel between the sun and the nearest star. Human spacecraft move far more slowly. Probes launched from Earth would require tens of thousands of years to reach even the closest stars. Travel across the entire galaxy would demand journeys lasting millions of years with current technology. Communication suffers from the same limitation. Messages cannot travel faster than light. If a civilization existed 20,000 light years away on the other side of the galaxy, a signal sent today would require 20,000 years to arrive. A reply would require another 20,000 years. Entire civilizations might rise and disappear during that time. Two intelligent species separated by such distances might never communicate simply because the universe operates on timescales too vast for meaningful conversation. The enormous scale of space also limits exploration. A civilization hoping to visit nearby stars must invest immense energy and resources into building spacecraft capable of surviving long journeys. Even advanced societies might find such missions difficult to justify. The vast emptiness between stars contains almost no material to support life. A starship traveling through interstellar space must carry everything required for survival, including air, water, food, and energy. Maintaining a functioning ecosystem for centuries or millennia inside a spacecraft could be extremely challenging. These difficulties suggest that many civilizations might remain confined to their own planetary systems. They may observe distant stars through telescopes, just as humans do, but never attempt to cross the enormous gulf between them. Another possibility examines the conditions required for life itself. Although planets appear common, the precise circumstances that allowed life to flourish on Earth might be rare. The planet orbits a relatively stable star that shines steadily for billions of years. Earth also possesses a strong magnetic field generated by movements within its molten core. This magnetic shield protects the atmosphere from charged particles streaming from the sun. Without such protection, solar radiation could gradually strip away the atmosphere and expose the surface to harsh conditions. The planet also maintains a dynamic interior that drives plate tectonics. These slow movements recycle carbon and other elements between the surface and the interior, helping regulate the climate over long periods. Earth's large moon plays another important role. The gravitational influence of the moon stabilizes the tilt of the planet's axis, preventing extreme changes in climate that might otherwise occur. All these factors combine to create a relatively stable environment where life could evolve over billions of years. The chain of events leading to intelligent life may contain many steps, each with its own challenges. The earliest life on Earth consisted of microscopic organisms capable of simple chemical processes. For nearly 2 billion years, life remained limited to such simple forms. Then a major evolutionary innovation occurred when complex cells emerged. These cells contained specialized structures capable of performing different tasks. Later, multicellular organisms appeared, allowing groups of cells to cooperate and form complex bodies. Eventually, animals evolved nervous systems capable of processing information from the environment. Over immense spans of time, these systems grew more sophisticated until some species developed large brains capable of learning, planning, and communication. Each of these steps may have required rare conditions. If any stage occurs only rarely on habitable planets, then intelligent life could be extremely uncommon even in a universe filled with planets. This idea sometimes appears in discussions of what scientists call the rare Earth hypothesis. According to this view, microbial life might arise on many worlds, but complex organisms capable of intelligence could be far less common. Earth's long period of stability may have allowed evolution to experiment with increasing complexity. Many planets might experience more chaotic histories. Massive asteroid impacts, unstable climates, or violent stellar activity could repeatedly reset the evolutionary process before intelligence ever has time to appear. In such environments, life might remain simple for billions of years or vanish entirely after catastrophic events. Another explanation focuses on the fate of technological civilizations. Intelligence allows species to manipulate energy and reshape their environments. This ability can lead to extraordinary achievements, but it also creates risks. Advanced technology introduces powerful tools that could threaten the survival of the civilization that created them. Nuclear weapons demonstrate how quickly a species can develop the ability to destroy itself. Environmental damage provides another example. Industrial activity can alter the atmosphere and disrupt ecosystems that support life. Future technologies might introduce additional dangers not yet fully understood. Some thinkers suggest that many civilizations may eventually encounter challenges that lead to their collapse before they expand into space. These ideas connect to a concept known as the Great Filter. The Great Filter represents a stage in the development of life that is extremely difficult to pass. If the filter occurs early in the evolutionary process, then simple life rarely emerges in the first place. If the filter occurs later, then many civilizations may reach technological stages but fail to survive beyond them. The location of this filter has profound implications. If humanity has already passed the filter, then intelligent life might be extraordinarily rare, but humanity could continue expanding into the cosmos. If the filter lies ahead, then the silence of the universe might reflect the fate of civilizations that reached a similar stage and failed to survive. Another factor complicates the search for extraterrestrial intelligence. Time itself may separate civilizations as effectively as distance. The universe is billions of years old, while technological civilizations may exist for only brief periods. Human radio transmissions have been traveling into space for just over a century. If a civilization broadcasts signals for only a few thousand years before evolving into different communication methods or disappearing entirely, the window for detection becomes extremely small. Two civilizations might exist in the same galaxy but never overlap in time. One species might flourish and vanish millions of years before another develops the ability to build telescopes. This possibility suggests that the Milky Way could contain many planets where life once existed but no longer survives. Ancient civilizations might have appeared long before Earth formed, leaving behind ruins that have long since eroded away or been consumed by stellar evolution. Stars gradually change over time, altering the environments of surrounding planets. Some stars expand into red giants that engulf nearby worlds. Others explode as supernovae, scattering their material into space. The dynamic nature of the galaxy means that planetary systems constantly evolve. Civilizations arising in such environments may have limited time before cosmic events reshape their worlds. Astronomers continue searching for evidence that could reveal whether intelligent life exists elsewhere. Powerful telescopes examine distant planets for signs of atmospheric chemistry that might indicate biological activity. Radio observatories scan the sky for unusual signals that might originate from technology. New instruments analyze patterns of starlight for evidence of massive structures that could surround stars. These searches continue expanding as technology improves. Each new discovery adds more information about the conditions that shape planetary systems and the potential for life. Despite these efforts, the central mystery remains. The universe appears rich with stars and planets capable of hosting life, yet clear evidence of advanced civilizations remains absent. This silence may reflect the immense scale of space, the rarity of complex life, the fragility of civilizations, or the separation of intelligent species across vast stretches of time. Each possibility offers a different explanation for why the night sky remains quiet, despite containing so many worlds. The search continues because every new observation deepens the understanding of how life and intelligence might emerge within the cosmic landscape. Across billions of years, the universe has continued its silent expansion. Galaxies drift farther apart. New stars ignite inside clouds of gas. Around many of those stars, planets slowly take shape. Most of those worlds will remain dark and lifeless. Some may hold oceans, mountains, and skies. Yet somewhere in that vast cosmic history, on one small rocky planet orbiting an ordinary star, something remarkable happened. Matter arranged itself into living systems. Those systems slowly evolved, gaining complexity over unimaginable stretches of time. Simple chemistry became biology. Biology became intelligence. and intelligence eventually built instruments capable of studying the universe that created it. This may be one of the strangest possibilities in all of science. The universe might be filled with galaxies, stars, and planets, yet the number of places where atoms organize into thinking minds could be incredibly small. Consciousness may not be a common feature of the cosmos. It might be rare, fragile, and brief. The long chain of events required to produce intelligent life might succeed only in very special circumstances. A stable star, a suitable planet, a long period without catastrophic extinction, evolution slowly experimenting with new forms until a species appears that can ask questions about existence itself. Humanity now stands at that strange point in cosmic history. A species made from stardust has begun studying the laws of physics that govern the entire universe. Telescopes observe distant galaxies whose light began traveling toward Earth billions of years ago. Spacecraft explore nearby planets and moons. Powerful detectors measure invisible particles and radiation coming from the deepest regions of space. Step by step, humans are learning how the universe began, how stars are born, and how the building blocks of matter behave. If intelligent life is common, then somewhere across the galaxy, other civilizations may also be asking these same questions. They may be studying their own skies, wondering whether another thinking species exists somewhere beyond the stars. But if the silence of the universe reflects a deeper truth, the situation becomes far more profound. If intelligent life is extremely rare, then the thoughts occurring inside human minds may represent something extraordinary. Conscious awareness might be one of the rarest phenomena in the cosmos. That possibility changes the meaning of existence itself. The universe may not simply be a collection of stars and galaxies drifting through empty space. Through conscious beings, the universe gains the ability to observe itself. Every scientific discovery becomes part of a larger process, where the cosmos slowly understands its own structure. The laws of physics that govern distant galaxies are the same laws operating inside the atoms of human brains. In a very real sense, the universe studying itself through conscious observers may be one of the most remarkable outcomes of cosmic evolution. This perspective also carries responsibility. If intelligent civilizations rarely survive long enough to explore the stars, then the future of awareness in this region of the galaxy may depend on what happens on this one small planet. The choices humanity makes in the coming centuries could determine whether intelligence spreads beyond Earth or disappears before reaching the wider universe. The silence of the cosmos might be a warning about how fragile civilizations can be, or it might simply reflect the immense distances separating islands of life across the galaxy. Either way, the mystery remains one of the greatest scientific questions ever asked. Are humans alone in the universe, or are there distant civilizations waiting to be discovered somewhere among the stars? Every new telescope, every new spacecraft, and every new scientific breakthrough brings humanity a little closer to understanding the answer. The search continues because the stakes are enormous. Finding even the smallest evidence of life beyond Earth would transform the understanding of humanity's place in the cosmos. Until that discovery happens, the night sky continues to hold its quiet secret. Billions of stars shine across the galaxy. Countless planets orbit those stars in darkness. Somewhere among them, life may exist, evolving slowly under alien skies. Or perhaps the rare spark of intelligence has appeared only here, on this small world, circling a modest star in the outer region of the Milky Way. If that second possibility is true, then every moment of curiosity, every act of discovery, and every effort to understand the universe becomes even more meaningful, because in that case, the human species may not just be another life form in the cosmos. Humanity may be one of the very few places where the universe has learned to think. If this journey through physics and cosmic mystery changed the way the universe looks to you, then stay connected with this channel. Like this video so more people can discover these ideas. Share it with friends who love science and big questions about reality. And subscribe to Feynman's Chalkboard, where each video explores the deep logic of the universe and the strange truths revealed by modern physics. The deeper science looks into reality, the more surprising the universe becomes.